graduation check this morning.
Come again?
I did my graduation check.
Nice. So this is.
It's like
Spring.
spring, yeah. This
I'll be
is
there.
Are you
Morning
gonna-
or afternoon?
morning, it's at 10 a.m. on the 6th.
I'll be there. Wilcoxon Rank Sum. Last time at the very end, I talked about this. What type of test is Wilcoxon Rank Sum? It's a non-parametric test, and what is a non-parametric test?
Small samples.
Distribution free.
It is distribution free. Can't elaborate, Jonathan?
There's no set distribution. It's just a bunch of random data. No, that's not it.
There is no set distribution assumption. So for a t-test, what is the assumption? We want the null distribution to be normally distributed. In the sense, the sample distribution has to be normally distributed. You adjust it, you end up getting a t-distribution, which will be the null distribution. But here, we don't have that assumption of a distribution, hence distribution free. The example that we did violated all kinds of assumptions last time. So we will do this and then we can continue with that example. Clearly, there is a sum that we need to find. There is a rank found by Wilcoxon, hence the name Wilcoxon Rank Sum. All non-parametric tests are based on ordered statistics and their ranks. In the sense, you have to put the data in order, get the ranks with the data, use the ranks to find the test statistic. What is the ordered statistic to measure center of the sample?
Median.
The median. Mean does not account for order, but median does. You have to put the data in order, then you find the median. Wilcoxon Rank Sum is a two-sample test. We are not going to go or get into too much theory. It's an applied class. Non-parametric inference, we went through a lot of theory. The idea is you have two samples, X and Y. Of course, we want them to be independent. I have two sample sizes, N1 and N2. The requirement here is N1 has to be less than or equal to N2. And you'll see why. Of course, you could do it the other way around, but I don't want to confuse you with too many variations. So this is the case that we will use. Sample size for X is N1, sample size for Y is N2. I'll explain via example. Better. Again, I usually would not start this way, but this is an entire class. So let's say I have two samples, 5, 4, 6.5, 7. Another 4.5. No. 4.26. And no. What is the sample size for the first one? X. Easy.
6.
Is N1 less than or equal to N2? Yes, but we are going to compare one observation with the other. So there is nothing to compare here, correct? So we will discard. Way back when, before computations was advanced, people used punch cards. The only way to come up with a test is to discard. But now that we have better computational resources, we can use something called bootstrapping to come up with a more accurate result. Beyond the scope of this half, I won't do it. So there is another measure. So we want to find the number of times xi is greater than y. Good. So that has dij there. Erases that. Right, x over here, y over there. Good. Number of times that xi is bigger than yi, that is going to give us dij, perhaps a new dij over here. And write the statistic as well. Let's not use, there is a cautionary tale that people who took non-dramatic entrance might remember. You know the confusion with W and U when we do it in R. A part is U. Is xi bigger than yj in that case? Yes. So check. How about that? Check. 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 No.
Overall,
No, 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 no. Okay.
equals greater, or is that, does it count?
That's have a full. There is a tie. Let's see. I don't want a tie. I'll tell you what. I'll make that 4.1. I'll make that 4.5. Oh, no. 4.6. This way, there are no type observations. I'll explain as to why that's important. So that is 4.1, 4.6. It is not going to change the first row. What about the second? Doesn't. Here, yes, no, 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 no. Yes, yes, very small. Add them all together. So we have 10, 11, 12, 13, 14, 15. Good. You up there will be 15. W, first sample, N1 times N1 plus 1 divided by 2 plus U.
Wait, we're adding all the checks together.
If you want things to be easy, you could put 1, 1, 1, 1, 1, 1,
Okay.
add all the ones. Why 2 letters? First one here, U. It's called Mann-Whitney Houston distance. W is Wilcoxon Rank Sum. Good. Wilcoxon came up with the test first, and then Mann-Whitney improved it and said, well, we don't even need this part, we can simply use DRJ to come up with the conclusion. So I have 15. Over there, N1 is 5 times 5 plus 1 is 6 divided by 2. W is 30. Good. So W is the Wilcoxon Rank Sum test distance. U is the Mann-Whitney test distance. And in both cases, we are going to look at the number of times where xi is greater than yj. Good. So we want to compare this with all of those, that with all of those. If our reference value is the first sample, and I have that number expression right here. Any thoughts as to what that is? Math people, you should know. Does that remind you of the formula?
Yeah, it's the sum of the numbers here. It's the
Sum of first N1 natural numbers, right? So if you have 5 observations, and if they are naturally ordered, then you're summing 1 through 5 plus. So another reason here is if you have 5 observations, what is the median? 3, right in the middle, right? If you plug it in the formula, you know that the median has to lie right in the middle. Good. Our goal is to see how far the sample takes away or moves away from that value, which is the maximum of the sum of the first 5 observations, or 5 observations in this case. Good so far? So I get a number of 30. The objective here is xi in that bigger than yi? In other words, the null hypothesis is the median of the first sample median of X is greater than median of Y. Yes? What is the norm? You should know this by
It's
now.
less than Y.
Less than what?
Median Y. Median.
Oh, so close, Phoebe.
Median.
Yes, but
Less than or
it's
equal to.
less than or equal to. So what type of test is this? Is it left tail, right tail, two tail? It is two tail. Wait, two tail.
Oh, right tail.
Right tail, not bad. I should have- This is right tail. She is putting some sort of a spell. Right. Right tail test. And we want to know if my is close to mx or is it going far away from mx? If all of these values for y were less than these values, I would not have more check marks, correct? In which case, this number is going to be small. And I'm going to stick with that number. So I'm not moving far away from whatever the first sign is. But if I have more check marks here, then this number will be large, and I'm going to keep on moving far away. Good. So that is the principle of Wilcoxon test. I make no assumption about the distribution. I just have a bunch of observations, put them in order, got check marks, and came up with the test statistic. If you Google, you will see a whole lot of variations or expressions in coming up with this test statistic. This is the one that your book does. And this is not non-parametric inference, so I will not talk about all variations. Yes.
So even though you discard 9, you can still say that the sample size of y is greater than the sample size of x?
Yes.
Okay.
Go ahead.
Did you discard 9?
But it's a great question. I simply dropped this because it wasn't a very fair. So on an exam, I will tell you which one to draw. Or I will just give you a case where n1 is equal to n2. That is the simple case. Again, if we encounter a scenario of this sort, we can shuffle this over and over, come up with a whole lot of statistics and see the number of times we detect. Good. Requires a lot of word computation. Are we clear? Now, I got rid of the ties. I changed these values because the variability in the test statistic will be affected if you have ties. Now, when you rank stuff and you have ties, I'm not sure if you remember, I guess we can erase this now. Yeah. This is the sample X. And I want to assign ranks. Rank simply means the position. It doesn't matter whether you go from lowest, smallest to largest, largest to smallest. Typically, ascending order, right? So, observation, rank. Let's start. What is number 1? Sydney. 3, 2. Agreed. And this is the reason why we do n1 times n1 plus 1 divided by 2. Sum of all these rungs. Good. If I have too many cases where x is bigger than y, I'm going to go farther and farther away from the sum of those rungs. Do you agree? Making or giving us more evidence to support the alternative. That is the logic. Now, hypothetically, if those two were equal, hypothetically, not this case, how would you solve it up? Let's try this again.
You add the roots together.
So I'll assign 1. If that were to be different, I assign 2, 3. But here, since they are the same, I'm going to assign the average of 2 and 3, which is 2.5. I have accounted for 1, 2, 3, so that leaves me with 4 and 5. Yes. N1 times N1 plus 1 divided by 2 over here was 15, correct? When we did not have ties, it was 15, correct? Add those values and tell me what you get.
Wait, I have a question.
Go ahead.
How did you know, like, where to put the 1, 2, 5?
The position. If you
Oh.
sort them, number 1 position, 3.
Oh,
After that, you have these.
got it.
If you add those, what will you get?
15.
Still 15. Do you agree? So the average of that statistic will not change. It'll always be n1 times n1 plus 1 divided by 2. What will change is the variance. So because of that reason, we don't want ties. A case like this will affect variability. If it affects variability, it will change that condition. Good. So this statistic W is called Wilcoxon Rank Sum because it incorporates the sum of the ranks. However, Mann-Whitney doesn't. It simply counts the number of times xi is bigger than yj. The key difference between W and U. So, considerations, can I raise this?
Yeah.
Presence of ties that is going to affect your conclusion. In this class, we will do the case where we don't have ties. We want to keep it simple. When I assign the reading, I hope you read. Phoebe.
Yes, hello.
And Diane. So you will see the expression for variance is pretty huge, and we don't want to do that. I'll write the simpler case after we do the example. So first consideration, presence of ties. We don't want ties usually. Second, if n1 is not equal to n2, which ones do discard? Here, I picked a convenient one, but typically we shuffle this over and over at least a couple of times to see how many times. Okay? Way back when we did not have computers or advanced computers, people did this manually. They would probably do it 5 times. Shuffle this around, get 5 W's, count the number of times out of those 5 times that you rejected. If 3 out of 5 times you rejected, it's more likely you will reject. But is that accurate then? No. 5 times, not good enough, especially if you have a sample where you have 15 observations there and 25 that presents a problem. Good. Pause. And recognition. When we did a pad test, I mentioned whether you do after minus before minus after will affect your conclusion. Same here. The way the test is constructed here is by comparing xi to be bigger than, yj. But there are cases where you could do it the other way around. Here's the question. Does that matter?
I don't know. Wait,
For
what?
you, it does.
Yeah,
So we always test for xi greater than yj. But is that a serious condition? I can simply swap and give it a different letter, right?
oh, true.
So it's not a big deal. But the reason I'm putting this here is because that's what the book uses. Good. Again, cautionary tale or advice. If you Google, you will see a lot of variations for this test statistic. All of them lead to the same conclusion, but the derivations are different. Good. Okay. Ooh. Very important before we get to on. Can I erase this?
Yeah.
Write it in red. I said red, so I'm using black.
Caution.
Caution. What we have here as U in R, it'll be listed as W. You may say, well, why? Well, some programmer who first programmed this messed up.
Idiot.
Exactly. Thanks for giving credit to that guy, to that person. Poor guy, poor guy. And I don't know, no one considered to change it. But what we have here as U will be listed as W.
So what's W?
Huh?
So what's W?
It's not this W.
Yeah, but so are there like 2 W's?
No.
So what's
So
W?
when you look at the summary
Okay,
in R,
okay,
you will see a W.
Yeah.
That W actually corresponds to U,
okay.
right? But if you know this, you know that. Correct.
So what
Um,
represents the Wilcoxon Rank Sum test?
that expression.
So there's no variable for that one? There's no letter that represents it.
W.
In
In
R.
An R.
In R, no. So R can only give you.
I was like,
I see, R can only give you, but programmed as W. But once you know U from R, you can find W manually.
Got it.
So R will always give U, but misrepresented as W.
And it doesn't give the Wilcoxon Rank Sum statistic, we have to find out ourselves.
Yeah.
Okay.
We went over this over and over again in non-prompting inference.